So yeah, we will wait for some more time. Others, see you with another students. Otherwise, we will start in like 5 minutes. So we'll start by 6:10. But if you have any doubt, from the last week question answer session, then you can ask me, okay, if you have any doubt. Hello. Yes. Yeah. So can you see my screen? Over a second. Yeah, so this is your second class mainly for the tutorial. So this is Rahuldev Ghorai from School of Mathematics at Thiruvananthapuram. I'm a research scholar here. So we'll start the second class mainly for our tutorial. So the topics which will be covered in this class, those are limit of functions in the two variable, the continuity of the function of two variables, the partial derivative of functions, and the partial derivative of higher order. That all the partial derivatives of higher order will not discuss mainly in this discussion, but little bit will go, okay, if time permits. So the last lecture, what we did is we tried to find out some of the limit. So what we did in the first class, those were in the real line, the set of real numbers. So in the set of real numbers, when you try to approach a point, let's say you are going to approach a point here, some this point you want to approach. The real line you have a you can approach from this side, you can approach from also this side. So when we try to find a limit, we try to see whether both side limit exist, and they like whether they exist first of all. If they exist, whether they are equal, then the limit at that point, let's say this point is x naught, and then we say limit at that point will exist if the both side limit of that function exist. I mean, you have a function size, suppose like f of x, sorry, f of x, not f of x, not f of x. then you try to mainly find out the limit as x tends to x naught plus and of f of x, and limit x tends to x naught minus of fx, whether they exist and whether they are equal. All these things you try to find out. Okay, and we have seen in some situations that even though you you find one limit maybe this exists, one limit might not exist, even two limits exist, they might not be equal. So all those cases we will consider as limits does not exist. Or like I told in the first class also, we'll like denote this as a DNE, like does not exist when it does not exist. Okay, and yeah, so those things we did. So but what I mean here, what I wanted to say here, when you are in a real number, then you have two way to approach from right hand side and from the left hand side of that point. But when you go to, let's say, sorry, when you go to R2 mainly, so what happens, suppose you have a point here, so that it follows, this is some x naught y naught, if where x naught y naught are set of all real numbers. So, so x naught are real numbers. So then x naught y naught will be in R2, and that point you can approach from infinitely many, through infinitely many paths. Like you can approach from through here, you can approach from here, you can approach from here. It's no, like there are infinitely many ways. So in the two variable function of two variables, so when you check the limit, when you can check, you cannot just say that there are two way, and if you just check whether in that two right hand side limit and left hand side limit approach, and you say that that exist and they are equal, some that those things you cannot say. So you have to like approach through like almost all the paths, like all approach through all the paths, but that is not possible because there are infinitely many way. In the real number, what you can see, you can, if you can just check only these two, and if they are equal, then the limit exists, that you can say. But here you cannot say to this that thing because it's a not finite number, means there are only there are infinitely many way. So what we'll do here, so when the limit does not exist, in that case, we'll use this criteria. If it is one of them, one of the paths through one of the path, it does not exist, or in the two different paths, the limit is two different, then we'll say limit does not exist. But to show limit exists and what is the limit, we cannot go through this way. Okay. So we will see that. So that this is the formal definition of your limit mainly. It says that the f of x y has a limit at x naught y naught if the distance between f of x y and L becomes arbitrarily small, whenever the distance from x y to x naught y naught is sufficiently small but not exactly zero. Okay. So mainly if you have a function like this, suppose you have a function like this, and here some x naught is there. So x is approaching some variable you are taking. So x is approaching to x naught from this side, or if it's in the real number sense I'm talking now, then what will be the function behavior at this point? For this function, I draw the function, but some of the functions you will not understand how the limit is, so to know the limiting behavior there. So yeah, so that, yeah, now we see that if this limit L, we see the limit this L, if L may or may not be always the f of x naught y naught value. Let's say you have a function like this where it is like let's say f of x is a one function that is 1 when x is less than equal to 0. Sorry, I will write maybe less than 0, and x is greater than, for x is greater than 0 it is 2, and when x is equal to 0, no, let's say x is greater than 0 also, 1 and x is equal to 0, it is 2. We can define this type of function, right? So what happens to the limit of x tends to 0 plus of f of x? What will be this? All of you must know this. What will be this? This will be also 1, and also the limit. But what is your f of 0? In this case, this 1 is equal to L. I mean, L is 1 here. But what is f of 0? That is, I mean, it's one variable thing now in one variable, so that you can just take it into the two variable. So f of 0 is equal to here 2. So the limit is not equal. This function is not continuous, although limit exists at that point. So here is the limit and continuity difference comes. So continuity will follow then if the limit exists and that limit is equal to at that point value of the function. Okay, so yeah, that this is what we have discussed, that in R, when you check the limit at a point x naught, then we have only two directions. From here you can approach to x naught, and in R2 we have infinitely many directions. From here you can approach to x naught, y naught. So mainly depending on these things, we will be doing some questions. So it's the first question here. So find the limit of 4x y square over x square plus y square when xy is converging to 0. See, by seeing this, you cannot just predict what is the form, like how it is behaving. It's like you can think like 0 by 0. It's not actually 0 by 0 form. Okay. So remember that 0 by 0 form you do in the real number set. I mean the 1 by 1, only one variable thing. So it's a two variable you cannot use here. Okay. As such, you cannot use here. So how to proceed with this? So what will be the solution? How to predict whether it exists first of all? If it exists, what will be the limit? Everything we know, nothing we know, right? So we see what is this 0 point where it is? It's a origin, right? It's a 0 here. So as I said, you can approach through many different directions to 0. So you can come from here with any, like it can be curve also. It can be straight line like this, from this line through this line you can approach. Okay. So I want to see, suppose this is a y-axis, right? This is a y-axis, x-axis. Suppose I want to know when a point is approaching to 0 through y-axis. Let's say through y-axis. So through y-axis, what happens? X is equal to 0, right? X is equal to 0 and y will vary. Y is not equal to 0, but y is tending to 0. So that is not it. This means that some x naught, this xy is converging to 0. This is also in through the path, through through y-axis, right? So x is equal to 0 and y is tending to 0. That implies you were maybe approaching from here also, or any of the direction. So that implies you were approaching to 0 through a path y-axis, that is y-axis. So there what we will see is 4xy square over x square plus y square, that will be 0 because x is equal to 0 there exactly, and 0 square plus y square, so that will be 0. So what you can say that in that path means through y-axis the limit x y tends to 0 0 through y-axis. You can think like that, through y-axis. That is of 4xy square over x square plus y square, that is equal to 0. You can take any some other path also. Is maybe usually what you will do when this is like 0 0 type of this type of equations are there, sorry, this type of functions are there, you can approach through also x-axis. So you will see if you approach through x-axis also, it gives you 0 0. Sorry, it gives you also the 0 function. So the function value, the limit will be 0 when you approach through x-axis also. Even if you take some other lines, let's say yx equal to x. Okay, so I don't have place for it maybe. So this when y is equal to x, so your limit as xy tends to 0 0, that of the function fx will be limit as x and again x that tends to 0 0 f of xy, sorry, f of xy, f of xy, that will be your 4x cube over 2x square, that will be again also 0. X square will go and it will be 2x, so limit x tends to 0, that will be 0. So what you can see that kind of all the standard way, let's say standard path, the y equal to x line, y equal to 0 line, x equal to 0 line, what we see the limit is 0, so we predict that that limit might be 0. Okay, so that's how we can predict that the limit is 0, maybe it will be 0. So now we proceed to prove that this is a solution and is. So the if the limit exists, it will be 0 because the limit of a function is unique. Okay, so the function here is 4x square over y x square plus y square. So what you can write, 4 times modulus x times y square, right? That is be equal to this. And now you use a simple inequality like this. This will always be even modulus of y will be less than also x square plus y square. But I don't need this one here, so I need this one here. So if we plug in this one here, so what we get, 1 x square over y square, square root over x square over y square will go, and then we can get this, right? What I have used here, so this one, how you got this one? So y square over x square plus y square, that is also I have taken, that is less than equal to 1. Okay, that is also true, right? See, because x y are conversion to 0, that implies x and y, x you cannot, you can take x is not equal to 0. Okay, for now. So y square over x square plus y square, that will be, I mean, x square plus y square is not equal to 0, right? So that you can assume. So y square over x square plus y square, so that will be less than equal to 1. Okay, so then this one follow, this quantity and this quantity will give you this one. And then what you see, if you take limit on both sides, limit as x tends to 0, sorry, x y tends to 0 0, this will give you limit x y tends to 0 0 of this quantity. So that what is that? That is nothing but x square plus y square. When limit x y tends to 0, that you know x is conversion to 0, and that implies that limit is 0. So limit of the function. So the limit of the function exists. Yeah. So answer is yes, exist, and limit is 0. So any doubt up to here, please ask. Okay. No doubt. Okay, so if there are no doubt, we'll proceed to the next question only. Okay. So yeah, that's right. So the next question is this. So find the limit of f of x y, and that's at the same point 0 0. Okay. Mainly, you need to find out the limit x y converging to 0 0 of this sine x square y plus x y square times x y. Can you try with? I will give a hint here. Maybe hint is you use some limit t tends to 0 sine t over t is equal to 1. You use this thing, this known limit to prove this one. This thing. It's easy, right? Then? So what we observe here is, so I'll maybe doing this. Yeah. So limit mainly what you are getting it's y. Okay, for writing limit, we'll see the what is the function. Okay, so how is the function? Sine of x square y plus xy square. X square times y plus x times y square over xy. Okay, this you can write as sine of xy times x plus y. You can always write over xy times x plus y. You can again write times x plus y. Can you do this? Can always do it. I'm assuming x plus y is not equal to 0. Okay, x plus y is not equal to 0. So find the limit of this through when y x equal to y equal to minus x. Then we will. Okay, let's say x plus y is not equal to 0 for now. Okay, this is the first case maybe. Okay, case 1, x plus y is not equal to 0. So then you can do. Then what will happen? Now I'll take limit. So I can always do this. So limit as in this case 1 when x plus y not equal to 0, but xy still can go to 0, converts to 0. So xy converging to 0, 0, 0 sine of xy times x plus y over xy times x plus y times limit of the limit of whole function can be written as like this limit as xy tends to 0 0 x plus y. Now what we see, this we can write as limit as when xy tends to 0 0, you can always say that xy times x plus y that is converging to 0, right? Times sine of xy of x plus y over xy times x plus y. So this is one quantity. You see some t. This is like t, and sine t over t when t tends to 0, that will be 1. And here you know already xy tends to 0 0. This is x plus y. So that gives you 1 times 0, that is 0. So limit is 0 when x plus y is not equal to 0. I have assumed. Okay, through that path you can show that case 2 when x equal to minus y, so that will be nothing but sine of sine of 0. I think so x will be minus y, so minus, so y cube and sine of 0 over minus y square, so that will be 0 function always. So if when x equal to minus y, that will be 0 function. When you take limit, that will be also 0. So the limit is 0. That is what we are calculating. So see, I'm showing in two different ways. There's one for the first one. For the first one, we have seen we approach through two different side and we try to find out what's the limit because we don't understand how the limiting behavior limit will be. And we then use the definition type of thing. I mean, take the distance of the function with the 0 point and with 0, and then we see that the distance is becoming very closer when xy converges into 0, 0. And here we see why we do like that. Then why we do like this, because we know something is sine of t over limit of t tends to 0, sine t over t is equal to 1. And once this quantity is 0 and this quantity is 1, then 0 times 1 will be 0. So that it will just step forward to it. Okay. So that was the second question we discussed. So any doubt here? Yes.
Sir.
Yes, tell please.
In second sum, we got this limit as 0, the answer.
Yeah, second one we got limit as 0.
What is that mean, sir?
Sorry.
What is that mean that?
Yeah, so that for
What is
I
the meaning of
start
that?
we maybe came late. Yeah, so there are precise mathematical definitions of there, so which I am not going to that, but the limit said this is the definition. You see now, you please maybe read, or what I say this as xy tends to 0, here x for your case x naught is equal to 0, y naught equal to 0. So if you make this xy like xy close to 0, 0, then of xy will be, for your case the L is 0, so f will be close to 0. So whenever you make xy close to 0, 0, f of xy will be close to that 0 point. So the function we have like that way, like xy will be like the xy will be when xy is close to 0, 0, the function will converge to 0. Function is going to 0 only. Okay. Function, but in the small neighborhood of 0, the functions will be there. Whatever close neighborhood of 0 you take, see, okay, I'll show you maybe. So suppose let's say the function is like this, and you take some, this is the point 0, 0. Okay, if you take some small neighborhood here, whatever neighborhood you take, I can give you one neighborhood. So this first of all, the map has to be not in the two dimensions. It's not in the two dimensions. So if it is a one dimension, so if the function is converging to 0, I mean whenever you give me one neighborhood of 0, 0 point or the 0 point, I can give you a neighborhood of 0, the limit. In that neighborhood, the function value will be there from this neighborhood. I mean, you have xy that belongs to neighborhood of some small delta neighborhood we call of 0, 0. For all xy belongs to the, for all this, we'll see this f of xy, all those xy, f of xy will be in the neighborhood of that, sorry, not this same neighborhood, epsilon neighborhood of some L. I mean, a small neighborhood. I just make a neighborhood, some different definitions. It's a neighborhood mainly, the set containing 0, 0, set containing here L. So if you start with epsilon, very small number, then you will have a neighborhood of that point, the limiting point. And in that neighborhood, what I will say, I can give you a delta, I mean, small number, such that all those xy belongs to the preimage of that function will be belongs to that same neighborhood of delta. I can give a delta of the limiting point. So from there only the function value will belong to the epsilon neighborhood. Is it now little bit clear, or I mean, which
It's
what?
clear. It's clear. Sir. It's
Sorry.
clear.
Okay. Okay.
It's clear, sir. It's clear to me.
Okay. So any other question? Anyone else also?
Sir, is there any general procedure to solve this problem, sir?
Yeah, so that's why it's not, at least I don't know whether general procedures are there. That's why I'm giving you many different type of like way to solve. That you see for the question one, I showed the limit exists, but you cannot just write by some manipulation 0 by 0 form or something. That's what we approach to different line or different different line or different curve to the limiting point, and we try to see the limit is always 0, like at least 2 3 way we did, and we see the limit is always 0. And in the second question, we see it's a kind of known type of functions. We see in a known form, like we can make it sin t over t type of like this, and that's why we do simple thing. So I think these are it will be after we do lot of questions, it will be, you will also get to know how to deal with these things. So it will be easy. We just have to do more questions, more practice questions, then it will come. It's no, I don't think there are general procedure to do these things. Yeah. Any other question? So this is what we did at the end, and then we'll move to the next question. Before that, I'll wait for some more time for your questions. Okay, so if no, then let's see this question. So how to deal with this question? We have seen, see, this is a similar type of things. We saw that x y square, I think it was x y square, the first question. First question here, it was x y square, the limit exists, and that is equal to 0. But even ask that why I repeated same type of question, it might be 0, but it's not. What we'll see, the 0 line is 0 point is here. If we approach, let's say from through x axis or through y axis, through x or y axis, the limit will be limit of xy over x square plus y square as xy tends to 0 will be 0, right? Because when through y axis, like we did in the first question, through y axis the x is equal to 0, so you put x equal to 0, then you get 0 only, the function will be 0. So limit, here I am not writing anything else, limit through x or y axis to 0, okay, to origin. But you see, if we through y is equal to x line, see, y is equal to x line also passes through 0 so that will also, we can take limit through that path also. So through y equal to x line, the function, so if we can write function f of xy will be nothing but f of x times x. Here f of xy is equal to xy over x square plus y square, for your information. So that implies this is equal to x times x over x square time plus x square. What is this? 1 over 2. Okay. X is not equal to 0. 1 over 2. So limit, then in this case, limit will be limit of f of xy as xy tends to 0 through the y equal to x axis will be half. See, if you go through x-axis or y-axis, you are getting limit. If you go through x-axis or y-axis, you are getting the limit 0. If you are going through y equal to x line, you are getting limit as half. Even we will see if we go through, see, that's what I have written. So observe that the function has value half along the x equal to y or y equal to x line, and 0 along the y equal to x equal to 0 or y equal to 0. Even the function, if you take y is equal to 2x line, y equal to 2x line also will pass through. See, if you have y equal to x here, y equal to 2x will be here. So all those lines will be passes through the 0 point. So then f of xy will be f of x 2x, and that will give you 2 times x square over x square plus y, sorry, x square plus 4 y square, right? Y equal to 2x, 4y, sorry, 4x square. So that means that give you 2 over 5. So if you go through y equal to 2x line, so mainly if I now write limit xy tends to 0, 0, f of xy, if limit x is, that will be equal to limit as x tends to 0, f of x 2x, and that is nothing but limit through the y equal to 2x line, that is equal to 2 over 5. So you get different limit for the different line. Even you can show that if you take y equal to mx line, some m is a constant, you can vary for different m, you will get the. So for the different line, you will get the different value of the function. So the limit is not unique, and all of us knows that this limit of a function is unique if it exists. So this function cannot have limit at 0, 0. You can check that at any other point it will have 0. So it will have a limit, but at 0, 0 it will not have any limit. The limit does not exist. So the different path gives different limit of the function here. So if that implies the limit doesn't exist. If limit exists, it has to be equal to all the paths. So in the R2 we cannot consider all the paths. So by doing one by one path, you cannot show that limit exists, but you can at least predict what is the limit. But when the limit does not exist, then you can use this path thing, like the converging through path. Okay. So this function has no limit, whereas x square over y times x square plus y square, or x times y square by x square plus, this has limit. Limit is equal to 0. Limit xy tends to 0, 0. This is equal to 0. But you see x times y over x square plus y has limit. Okay. So mainly you have to practice some questions, and you have to mainly find out whether you can try to see that whether y equal to x line or y equal to x square curve or y equal to x equal to y square, or some such thing, by some such thing, doing some such thing, whether can you show that the limit is not unique, limit is different for two different paths. If that is done, then you are done. You can say that it does not exist. If that is not done, then you can try to show that whatever the path you went through and you saw that limit is equal, kind of, then you can try to prove that the limit is 0, and that will have different procedure. Like different questions will have different procedure. Okay. This question is fine. The answer, and this yeah, also this question you can do using the polar coordinates. I can maybe write it here. So the mainly what we are trying to prove, xy tends to 0, 0, xy over x square plus y square. See, always you can, xy is a polar, sorry, the Cartesian coordinate you can transform to r theta, where x equal to r cos theta, y equal to r sin theta, right? And when xy tends to 0, 0, that implies your r will converge to 0. I mean, the polar coordinate, when you approach 0, it will be like helix type, or when you approach like this. R will be going to 0, but theta can be anything. Okay. So that implies limit r theta, sorry, angle may or may not be 0. R tends to 0. R cos theta. I am transforming the xy coordinate to r theta. R sin theta over r square cos square theta plus r square sin square theta. Okay, that implies limit as r tending to 0, r square cos theta sin theta over r square. Okay, why? Because cos square theta plus sin square theta is equal to 1 for all theta. That implies limit as r tends to r is converging to 0, so r is not equal to 0. So what you can write, this is right. So yeah, that is nothing but cos theta sin theta, and this quantity is independent of r, so that will be cos theta sin theta. Now you see, the if we change one theta, we take one theta, you can fix one theta, right? You can fix one theta and you can start approaching to 0. So for different value of theta, you get the different limit. Limit should not depend on the point, which path you are approaching. But here that is happening. If you change, you take a one theta and take r is converging to 0, you will see one value. You take another theta, you will see one another value. So the limit does not exist in both cases. We need two method mainly to so that this has no limit. Limit does not exist. Okay. It's fine. Okay. Then we'll move to the fourth question maybe. So try to do it whether you can try to do it yourself. Is it possible? So first one is x cube y over x to the power 6 plus y square. So x cube y over x to the power 6 plus y square. So here what you immediately see that if you take y equal to some m times x cube, right? So some m times x cube, then what will happen in through this path, the function will be x cube times m x cube over x to the power 6 plus m squared times x to the power 6, and that give you m over 1 plus m squared, right? So when you take limit as xy tends to 0, 0 of x cube y over x to the power 6 plus y square, if the limit exists, that should be equal to a limit as x tends to 0, xy tends to 0 mean x tends to 0 mean here through this x equal to y cube path, y will be also tending to 0 mainly. So that implies what you can write this m over 1 plus m square, because through this path it is like this, and this is nothing but m over 1 plus m square. So the limit depends on the path. I took this, you take y equal to x cube, you will get 1 by 1 over 1, like means 1 plus 1, that is 2. Another person will take y equal to 3x cube. See or he will get, that person will get 3 over 1 plus 3 square means 10, 3 over 10. So depending on the path, the limiting value is changing, so the limit does not exist. So first question answer is limit does not exist. Okay. So now comes to the second question, xy over x square plus y square. So xy over square root of x square plus y square. Limit as x y tends to 0 0. Okay. See, one trivial idea will be whenever you have this x square plus y square in the denominator, to try to change it to polar coordinate and see whether that works. Okay. So what you will see is x equal to r cos theta, y is equal to r sin theta, then square root of x square plus y square will be r only. Okay. So this limit, if it exists, then it will be equal to limit as r tends to 0, r square cos theta sin theta over r, and that is equal to limit as r tends to 0, r time sin theta cos theta. And you all of you know that this quantity is bounded, and when you multiply a variable which is converging to 0 and other term is bounded, also live about boundedness, it does not depend on r. And if for a fixed theta, for any fixed theta, it is 0. Any fixed theta, the r is limit r tends to 0, r tends to 0. So any theta you take, that is equal to 0. And that is how we prove that for any number, like through any path, you approach to 0 0 point, that will give you 0. So the answer is 0. So it becomes very easy here. Okay, that the limit exists and it is equal to 0. So you can here try to do the first question we did, y equal to x line and all, we will see always the limit will be 0. So let's say y equal to mx line. So what will happen? This mx square over x times square root of 1 plus m square, and that will be m over square root of 1 plus m square times x, and x is tending to 0, so limit this will converge to 0. So you will not see any different limit when you approach through different paths. Okay. So any doubt in this question? Yeah, if no, then we'll move to the next question. So I think I should leave these two questions for you. You can do it. If you have any doubt, I will do in the next questions, or like you can try. It is a homework. I think I will give you. Okay, so homework. Okay, these two questions. Whether I have given the answer also. The PDF, I will be sharing the PDF with you guys, where the solution is given also 3 by 2 and 0. Try to find out. Okay. For the last one also I give hint, and all the answers, all the questions answer is there, answer key is there. Okay. So then let's proceed to the fifth question. Okay. Fifth question. Yeah. So fifth question is like this. So this is a one very easy exercise here. We already have done xy over x square plus y square, xy over x square plus y square. What have we seen that yeah, y equal to mx line? Yeah, yeah. So what you have seen is limit as xy tends to 0, 0. I think this is a mistake we have done, maybe. This, what was the limit? So xy over x square plus y square. Yes, yes. So this will be the, please take it will be square root of x square plus y square. Okay. So if you take this limit of this function is 0, now at the 0, 0 point, this function is not defined. So we can take a function like this, or you can take some f tilde different function like this. These two functions you can construct. But when you see the, for this f, the f of 0, 0 will be 0, but for this f tilde 0, 0 will be 1. But the limit is always 0 for both the function f and f tilde. Limit xy tends to 0, 0 of f of xy is equal to 0, and that is equal to limit as xy tends to 0, 0 f tilde of xy. Both the function has limit 0, but we deliberately define in such a way that one function become continuous, one function is not continuous at 0, 0. So this is the continuity definition. Mainly here you do one exercise that can, because this function is not defined at that point, you put some value, different value, to show that that function is not continuous. Like you can break the continuity by this way, because the function as such at 0, 0, you put this 0, 0 value, it won't be defined, because like denominator will be 0, the denominator and numerator both will be zeros. So we define in such a way that okay, so please make a couple of note. I mean, this function I'll be writing here properly. Okay, these are xy, and here xy also table xy, xy. Okay, I will be writing here mainly properly. F of xy is equal to xy over square root of x square plus y square. Okay, that at 0 when xy not equal to 0, 0, when xy is equal to 0, 0, this is the function. This is limit exist at 0, 0, and continuous also, like we said, continuous also. But if we take a function like this, f of xy is equal to xy over square root of x square plus y square. But the other value, so when xy is not equal to 0, 0, but we take some number, a different number, where xy is equal to, when xy is equal to 0, 0, then what we'll see, limit exists at 0, 0, but not continuous at 0, 0, not continuous, not continuous. Okay, so the this is the example where you see the continuity definition, and you can, I think the picture is clear, at least little bit of this. So then we'll move to the next question. It's a good question. You try to solve it, okay, whether possible. So this f of xy is equal to x times sine 1 over y when y is not equal to 0, and 0 when 0 when is like otherwise, because here you cannot say when y equal to 0, because when y not equal to 0 mean other than this y equal to 0 line, other than this x axis, all the part, for all the part of the domain, the function value is x times sine 1 over y, and only in this line this the function value is 0. It's not at one point. Okay, remember. So now what we can see, this x times sine of 1 over y, this quantity is bounded. When y is not equal to 0, this quantity will be bounded. Anyway, when you are taking limit, You don't need to consider y just equal to has to be y or y has to be 0. When y has to be 0, that thing is not needed, right? So when x times sine 1 over y, this function, if I see that this time minus 0, that will be less than equal to some modulus x time sine of 1 over y. And the sine function is always less than equal to 1. So we can write like this. This is okay, right? So because this quantity is less than equal to 1. So when this happens, so when you take limit on both sides, you take limit as xy tends to 0, 0. So this will be nothing but equal to limit as x tends to 0 of this equal to 0. So the limit exists and it is 0. And what you see here, f at 0, 0, what will be f at 0, 0? When f at 0, 0 you are taking, so y is equal to 0. So it will come in this case. So f of 0, 0 is 0. So that is equal to f of 0, 0. So the what happens, limit as x y tends to 0, 0, f of x y equal to f of 0, 0. So continuous at 0, 0. Hello, can you see my screen? Anyone?
Yes, sir. Yes, sir.
Okay. Just I wanted to. So please check it if you have any doubt. Tell me. Like whether any issue is there.
Sir, can you repeat once y not equal to 0 means?
Sorry. Yeah, tell.
Sir, please repeat once y not equal to 0 means.
1 not equal to 0. I don't understand.
Y not equal to 0 means.
Y not equal to 0. Yes.
Please
Uh,
elaborate.
can you say? I explain. No problem. But tell me why I did not listen. You know this y. What is y equal to 0 line? This is y equal to 0 line, right?
Yes, sir.
Yeah. So the function is given that other than this line, I mean, I'll draw like this maybe. You will see it is y equal to 0 line. Other than this line, all other points, here, please, all other, oh, sorry, for all other points, the function is sine of 1 by y, x times sine of 1 by y. But when y equal to 0, then because in all these quadrant and all these other points, it will be y will be not equal to 0. So all those points, so for all those points, x times sine of 1 by y, but otherwise it is 0. Was that your, like, did it clear your doubt?
Okay, sir. Okay.
If you have any other query, yeah, you tell me, please tell me, no problem. Okay. So it's fine, right? This is mainly we have used here the sine function is bounded. So if this happens also, you know, this 1 over y also, this will be also bounded. I mean, so y is not equal to 0, that always you can consider. So xy is converging to 0, 0, then xy need not be equal to 0, 0. That case you can always take. Okay. Xy not equal to 0, that case you can take. Xy is not equal to 0, but it's converging to 0, that of course you have to use. Okay, so any other doubt here? So otherwise we will move to this question. This is a very interesting question here. So can you prove that this function is discontinuous? And let's try to first find out the limit of the function when x y is conversing to 0, 0. Yeah, so what I wanted to say here is okay. So you see here you have x square over x square plus y to the power 4 minus x. So if I take y to the power 4 minus x equal to x square, this will be a curve which passes through 0, 0. Some curve, I'm not drawing it properly, so don't think that this is the graph of this. So some graph like this, but it passes through 0, 0. So along this line, along this curve, we will move to 0, 0, and we'll see what happens. So along y to the power 4 minus x equal to x square, the function will be f of x y will be x square over x square plus y square. Sorry, x square plus x square, that is half. If you move, so if we go along y to the power 4 minus x equal to 5x square, let's say, then your function will be f of xy will be, see, your function is this, here also is f of xy is equal to x square over x square plus 5x square. So that is 1 over 6. I mean, if you take the limit also, that will be also 1 over 6. So you go through two different curve, you are getting two different limits. So limit does not exist. And remember that these two curve passes through 0, 0. Okay, that's why you can take this curve. Any curve you can take which passes through 0, 0, so that for two different curves they passing through 0, 0. But then if it is the function is giving two different limits, the limit does not exist. But if the limit exists, then it has to be unique. See, in for the solution as this, we take y minus 1 by y to the 4 minus x equal to m x square curve, we will get 1 over 1 plus m type of limit. So it depends on m. So depend on the curve. So for this, depending on m, the curve will vary and then the limit will also vary, and that implies the function limit is absolutely does not exist. So when limit does not exist, so if you try to take this f tilde xy, which is x square over x square plus y to the power 4 minus x, and here whatever function you take, so some c, some 10, 20, whatever you take, it will not be continuous. You cannot make it continuous by putting some value here also. So limit itself does not exist. What I mean that xy equal to 0, 0. So it is not removable in the mathematical language. It is there. Called the removable discontinuity. So this function is not removable discontinuity. You cannot remove the discontinuity. Okay. But for some function like this sin x over x, let's say sin x over x, in the one, so limit x tends to 0, this will be 1. So that limit exists, and you can remove the discontinuity by putting one value. So if x is equal to, let's say, sin x by x, but f at 0 does not exist, you just define f0 is equal to 1 to make it continuous. Okay. So anyway, leave that part, but the here your main target was to show that limit f of x y limit does not exist, that you have shown by closing through different curve, like what the 4 minus x equal to times x square, where n is a, like aim also bad, like if you vary aim, then the curve will be different, but they will pass through on same. Okay. Any question up to here? If you have any question, then please ask. Okay, so I will assume that you have don't have any questions. I'll move to this uh, function mainly, whether it is continuous or not. Can anyone try at least for some time whether this, can you do this one? And first of all, try to find out what is the meaning of this. So what implies this, implies what? What are the values of x, y for this? You will see x x modulus x plus modulus y. So usually what you have this modulus of, you used to see that at some origin or something was given, but here is some weird table, right? What will that like? What's the meaning of this? So is not it imply this implies x equal to 0 and y is equal to 0? Yeah, because they are positive numbers, and summation of two positive numbers or 0 implies both has to be 0. Okay. So if that is so, then the function you can mainly write, I'll simplify for your understanding, better understanding. This will be sin of x plus y over modulus x plus modulus y minus x y not equal to 0 when x y equal to 0, then 0. Okay. So now it becomes a little bit easier. I mean, it's not a little bit easier, it's just looking easier at least. And at least for your understanding. So from the function you cannot like kind of see the way, right? From the function it is not known, right? Like we cannot understand it. So as I said, we'll approach through different lines. What we have, this sign of x plus y over modulus of x plus modulus of y, right? This was the function. We have to find limit as xy converges to 0 0. Okay. Now let's say we approach through y-axis. Okay. So that implies x equal to 0. You can put x equal to 0. So limit, then in that case limit will be y tends to 0 because x is always 0 times sine of y over modulus of y. What is the limit? Anyone? Please quickly. What is the limit of this? We have done in the last class that this limit, whether it exists, if it exists, the limit value also we have said. First of all, tell me whether it exists. Does this limit exist? Not, right? We have seen this limit does not exist. So how you prove that limit does not exist here? Yes. I think we have shown the way that whether it exists, does not exist, or all these things we have done. Okay. It will be plus minus 1, y tends to 0, you take y tends to, when you take y tends to 0 plus, then the limit will be 1, and y tends to 0 minus, the limit will be minus 1. So check at least the last video where we have done this. The limit does not exist. Okay. So limit does not exist. So we took one path and we see that the limit does not exist. So the whole limit, it will not exist, right? Does not exist. So if limit exists, then you take any path, that limit will have a limit, and that limit will be equal. And if you find out one path itself where limit does not exist, then it exist. The whole limit does not exist. Okay. So that was the 8th question. So now we'll move to the partial derivative mainly. Okay, partial derivatives. So partial derivative mainly, I will write the definition, find out. So if any function is there, then f of x at some point a b will be equal to limit as h tends to 0. You take f of a plus h b minus f of a b over h. Okay. And for f of y at a b will be limit as h tends to 0 f of, or k tends to 0 mainly, to make it precise, make it distinguish, to make distinguishing, to make distinct thing, we make it k tends to 0 f of a b plus k minus f of ab over k. Okay. So this way you can this way you can find out the partial derivative at a point, and you can show that whether it exists. Okay. If it exists, the value also will find. If it does not exist, you will see from this limit whether this limit exists. Then you will say that the function has a partial derivative in the x direction at the point 0, 0. So at the point AB. Okay, if these two exist. Okay, so these two are important. Okay. So we use this definition to prove that the limit exists. Okay, then we take the function here. So function is x cube plus 6y square. X cube plus let me write it here. X cube plus 6xy square minus 8y cube over x square plus 2y square. Also maybe one mainly I will show that fx at 0, 0 of this function. This is f of xy, and when xy not equal to 0, 0, and when xy equal to 0, the function is given 0. So f of 0, 0 is 0. Okay, this two we know. So what will be this limit as h tends to 0? F of f plus h, f is 0. So 0 plus h, 0 minus f of 0, 0 over h, right? This is the definition. So that will be nothing but limit as h tends to 0. What is f of 0, 0 is 0, f of h 0. So f of h 0 over h, because f of 0, 0 is 0. That implies limit as h tends to 0. What is f of h 0? That will be h cube plus 6 times 0, that will be 0, minus 8 times 0 cube, 0 over h. That implies that is equal to limit as h tends to 0, h square, that is equal to 0. Right? So the fx, when the partial derivative of this function at 0, 0 exists, did I make any mistake? Okay, sorry. So there is a mistake. So please, you haven't see the thing properly. So what is f of h0? So f of h0 will be h cube plus 0 minus 0 over, there is another quantity, x square plus 2y square. So that will be h square plus 0. Okay. So that will make it h cube over h cube, and that is nothing but, so limit exists anyway, but the value will be different, that is 1. Okay, because a is not equal to 0, so you can take cancel both sides, both denominator and numerator, and then that will imply that fx exists, fx exists at 0, 0, and its value is 1. Okay. Yeah, so similarly you can do this FOI at 0, 0. I will be just writing here, you just complete it. Okay, k tends to 0, f of k 0 means 0 plus k is k minus f of 0, 0 over k. Let me write maybe properly, otherwise you might get confused. So there is k, and that you try to find out. This answer is also given. So okay, try to do it. So if you have any doubt, please ask. Otherwise, I move to these questions. Okay. But yeah, before that, please take a look at this for the solution and the function. Whether it's you can able to understand it.
Okay, so if no other question, we'll move to the no other questions, right? Any questions here? Okay, okay. So let's move to this question. Okay, let's think about this for some time. We'll do it. Okay. So the function is given 0 on the y-axis, and function is x over modulus x time square root of x square plus y square when x is not equal to 0. Okay, I mean other than the y-axis, function is like this. On the y-axis, function is 0. So try to find out fx 0 0 plus fy 0 0. Fx at 0 0, fy times 0, fy at 0 0. Find the value of fx at 0 0 plus fy at 0 0. Okay. Yeah, so any idea how we will do this? So the approach for this will be, so I mean, we just use the definition of the partial derivative, that is limit h tends to 0 f of, I mean, let me write it clearly, fx at 0 0. So what we do, limit as h tends to 0 f of 0 plus h comma 0 minus f of 0 0 over h. So what does that imply? This implies limit as h tends to 0. So what do you get? Limit when f at 0 0, it will be 0. So f of h0 over h. Now what is f of h comma 0? That is equal to limit as h tends to 0 h. This will be h over h square root of h square plus 0 square. H over modulus of h. That is equal to limit as h tends to 0 h over modulus of h times h times square root of h square plus 0 square will give you modulus of h. That will be equal to 1. So what I did here is modulus of h square plus 0 square, that is modulus of h. Okay. Then what we'll see is f of fx at 0 0 is 1. What we got is fx. We got fx at 0 0 is equal to 1. So now we'll try to find out fy at 0 0. What will be that? Sorry, what will be that? Limit at k tends to 0 f of 0 comma k minus f of 0 0, which is 0 over k. That implies limit as k tends to 0. What is 0k? 0k means the first coordinate 0. So the first coordinate 0 means this function is also 0. So 0 minus 0 over k, which is equal to 0. So what we get, fx at 0 0 plus fy at 0 0, that will be equal to 1 plus 0 is equal to. So 1 plus 0, so fx at 0 0 and fy at 0 0 will be 1 plus 0 will be equal to 1. So that is what, see this. So you just use simple definition of the derivative and then get this. It was beautiful, right? So try, see, we overcame now. So please check whether you can understand this. Then we will move to the next question. Okay. This is what we did. This is the, like, mainly this. Then from y axis also easily. Then we can show that the value, the value of fx at 0 0 plus fy at 0 0 will be 1. Yeah, so we'll then move to the penultimate questions maybe. I mean, after this we'll have one more question, then we'll finish this. So this is that question, penultimate question, that whether f of x at 0, 0, fy at 0, 0 exists. And if exists, find out the. So can you do this? So if here you will see fx at 0, 0 will not exist, but phi at 0, 0 will have. So it can happen that both does not exist also. It can happen that one exists, one does not exist. So all the possibility it can be there. Okay. So the first one, like fx at 0, 0, fy at 0, 0, like we do it usually, we can do that. So that I'll do for you. So this will be limit as x tends to 0 f of h0 minus f of 0, 0, which is 0 over h. That is equal to nothing but that limit h tends to 0, 5h plus 0 over h to the power 4 over h. Okay, that is nothing but limit as h tends to 0, 1 over h, sorry, 5 over h to the power 4 that tends to infinity. Limit does not exist, right? So limit, in this case, limit does not exist. This will be 5. Okay, so and this is h to the power 4, h to the power 4. So this converts to infinity mainly, plus minus infinity. So it mainly it does not exist. So it converts to, if you say it's conversing, then it converts to mainly the plus minus infinity also. Make it more precise. To make it more precise, it will be plus minus infinity. So h minus tends to, sorry, it will, sorry, make a mistake. So it will be plus infinity only. Okay, sorry. So mainly it does not exist when it is converging to infinity. It does. See, we have h to the power 4. So when h tends to 0 plus, or when it is going to h tends to 0 minus, the both cases it will convert to infinity. It's not plus minus infinity, but it does not exist. See. But if we compute it here, that fy at 0, 0, we'll see that limit will exist. So the function is, I write the function here. Function will be 5x plus 2y cube over x to the power 4 plus 2y square. Okay. So fy at 0, 0, if you try to find out. Okay. So if you try to find out, then that will be limit as k tends to 0 f of 0 k minus f of 0, 0 over k. That is equal to limit as k tends to 0, 0 plus 2k cube over 0 plus 2k square. I mean it was 2, right? 2k square minus 0 over k, right? That will be equal to limit as k tends to 0, 2k cube over 2k cube is equal to 1. So fy at 0, 0 is equal to 1, but fx, whereas fx at 0, 0 does not exist. Okay. So I can give you also another examples where both does not exist. That also can happen. It can happen that both exist. That with that example we have seen that it can happen that both does not exist also. And why we need all these things, we will see in the next when we go to the higher derivative, differentiability, and all. We'll see that when this thing exists, we can do some. We can say more thing about the function. We can we can say something about the higher derivatives also using these things. If fx exists, fy exists, and thus one of the thing we'll see some time this type of thing f of x y as 0 maybe we will see those things. When we will see this fx exists, fy exists, and f of xy also exists and continuous, if more than continuous, then you can show that f of y exists, that also exists, and that is equal to f of xy. Those things you can say over the function. But before that, you need to know whether fx and phi at that point exist or not, whether they are continuous or not. All those things we will need. So that's why this limit will be important when you go to the differentiability of the function and higher derivative of the functions. Okay, so there will be very useful. You will see in the lectures by Professor Jitendra Kumar. He will be also teaching you and these things and the higher derivative and difference. Okay, so any doubt here? So for your information, I can like for your knowing is a for your information, I will give you this fx y at 0 0. That mainly you can write as limit as h tends to 0. You are changing. Sorry, you're changing y, right? So means if you're changing x with respect to f of y, I mean f of xy is nothing but del del x type, or I mean derivative of fy with respect to x. So what we will have then, this quantity, what you can write, fy at h0 minus fy at 0 0 over h. So see, here you need fy at 0 0, whether that exists to know f of xy at 0 0. So once you know that, then you can compute, and also you have to know fy at h0 also. That's another thing. But before that, f of y is 0 0 also, that is also necessary. So you need to know those things. Okay. So at the end, I will be. This is the last question mainly. So we'll end this session by doing this. After doing this. Okay. So at least try to do by yourself. 1 or 2 minutes, then I will discuss it. Okay. So this type of questions might come in your NPTEL exam and all. So it will be these are finding out fx 0 0 fy 0 0. I have seen many places. And as is that your engineering exams and all. Okay. So yeah, so try to find out first if fx is 0 0 and tell me what is the answer. If you are watching offline also, you will be like you can do by yourself, try to do by yourself, then pause the video and try to do by yourself, and then check the solution what I am doing with it, and also check it whether it is correct and inform me if it's not correct. Okay. Yeah. So let's start. So what do we do? Our usual definition of x y at 0 0 will be limit as h tends to 0 f of h0 minus f of 0 0 over h. That will be equal to limit as h tends to 0 h. What is h0? F of h0? What is f of h0? Anyone? What is f of h0? F of h0 is 0 only, right? Because for the y coordinate, the function is 0 when the y coordinate is 0. So f of h0 will be 0. So that implies it becomes very trivial then. And f of 0 also is also 0, right? That is also true. So that implies the fs, I mean the partial derivative of f with respect to x that exists and that equal to 0. So you can show that the function is continuous also. That before that we should show the continuity. Okay, at the end we'll show the continuity. Anyway, it will, the question is given that it's continuous, so it will be continuous, but we can check that also whether it is continuous. Okay, first we'll find the limit and then we'll show the continuity and then we'll stop the class, end the class. Okay, so yeah, see this f of x. Sorry. We'll see some other the mistake is given in the solution. The fx at 0, 0 is 1, fy at 0, 0 is 0, it is given. Okay, we'll check, we'll see. Let's say the limit of, sorry, not limit of fy at 0, 0, fy at 0, 0 will be limit at as k tends to 0, f of 0k minus f of 0, 0 over k, that implies limit as k tends to 0, k tends to 0. What is 0k? Your 0k will be minus k cube sine of 1 by k over k, that will be equal to negative of limit k tends to 0, k squared times sine 1 by k, that will be equal to 0. So fy at 0, 0 is 0, but fx at 0, 0, that also should be 0. So there will be a correction. I will tell you, if you try first at least, then I'll tell you whether it is the function value like the fx at 0, 0, whether it will be 1 or not. Okay, see the calculation is here, so you check whether it's correct or not. Fx is 0, so y is equal to 0, so it will be 0. F at 0, 0 will be also 0, so this will be fine. I think it's correct. Okay, you check it once and let me know if there is any issue. Anyway, this lecture is already recorded, it's being recorded, and then it will be sent it to you. So both will be 0, 0. Okay, the both value what you find will be 0 and 0. So this will be 0. Okay, and we'll last that the end will show that the limit xy tends to 0, xy tends to 0, 0, this fxy, whether it is converging to 0, 0. Okay, what is f of xy is given to you, x minus y cube times sine of 1 by y, when y is not equal to 0. So modulus of f of xy minus 0, that will be modulus of x minus y cube sine 1 by y. Why I am thinking that this limit will be 0, like I said, because we see this sine of 1 by y is bounded function, and as xy tending to 0, as xy tends to 0 means y tends to 0. But when y tends to 0, sine 1 by y is bounded to s, so y cube times sine of 1 by y will be converted to 0, so I predict that this will be 0, and I will see here whether it is converting to 0. So modulus x plus modulus of y cube, that you can write as sine of 1 by y is less than equal to 1. Okay? So once you are done with this, so when you take limit as x tends to 0, limit xy tending to 0, 0, f of xy will be then, sorry, let me write it properly. That will be 0, because this quantity converts to 0 when xy is to 0. Right? So any doubt here? Don't be afraid to ask question. Okay. So I think I'll end the session by the question answering session is over. I'll take doubts if you have any doubt from the last lecture also, and last week tutorial session and today's tutorial session. These PDFs and all will be uploaded. Don't worry about that. But yes, if you have any doubt, you can just ask me now. Yeah, so then we will do the other, like the higher derivative and differentiability and all these things in the next tutorial session. So yeah, this video will be also uploaded in the YouTube, and I share it to the NPTEL guys the link of the video, and exactly like this PDF. I mean, whatever I did in this class also, that PDF also will be shared with you. Okay, this is 101, this is 0, and yeah, these are some books and references which I also refer and was referred by Professor Jitendra Kumar also in his that lecture tab in that NPTEL. So you can take one of the book and you can do exercises and all. And yeah, so I think that's all. And thank you for your attention. I'll still you have some 2-3 minutes for your question answer pieces. Like you have doubt, stop after 3 minutes. I will stop.